Squares. Fourth factoring method. You can use difference of squares when you're given two terms. Now, I don't think I put it on here, but you should, of course, always do GCF first. Okay, so you might have that. Then, if you don't, or maybe you do, then if you have two terms left, see if you can do a difference of squares. It's important to note you can only use difference of squares when you are subtracting two perfect square values. Now, the perfect squares, they could be a number or they could have variables in them. For example, 3 squared is 9. That's a perfect square. It could also be like x squared. That's a perfect square because it's x squared. It's like x then squared. So both those are perfect. So it could have variables or it could have numbers in it. Okay, here's the pattern. A squared minus b squared is a plus b, a minus b. And I'll simply FOIL to show you why it works. Okay, so watch. If I FOIL this, a times a is a squared. That's the f. O outside is a times negative b. That'd be negative ab. The I is b times a, or a times b, positive ab. And then last is negative b times b, b squared. And then the middle terms cancel, and you'd just be left with a squared minus b squared. Okay, so that's why if you have two terms squared, it could be a number or a variable, or it could have both in them. It could be a term with variable and number. Two things squared and they're subtracted. That's how it simplifies. A plus b, a minus b. Oh, and you could have the minus first. It would be a minus b, a plus b if you'd rather do that. So, yeah. Well,
wait, so if the equation were a squared plus b squared, would you do a plus b times a plus b?
so you think, what was it? A
Plus b, and then
So that's my question. Yeah, what's the next one going to be? A squared plus b squared. What does that factor into?
Nothing. It's fine.
Trick question. Yeah, it's prime. You can't factor that one. When it's plus and minus, the middle terms cancel. Over here, yeah, I mean, some people might say, well, what does it factor to a plus b, maybe? Well, no, because you'd have a squared, and then you'd have 2ab from the middle terms that wouldn't cancel, and a b squared. That's why up here, it's only when you're subtracting. It's only a difference. Difference being minus.
So all the classes on here are prime?
Well, not quite. Not quite. Let me show you in a second. So, any questions on those two kind of formulas? Yes.
so for all these equations, we're gonna have to figure that out. Like we're gonna have to do that. You're gonna have to do.
Yeah. Then we're gonna have numbers and variables down here, and we'll use that pattern to factor it. Yeah. Now, it's very helpful to have a good working knowledge of the most common perfect squares. We've got whole number, perfect square values. If you don't, yeah, you can use your calculator to help you out, but it's good to recognize perfect squares. So let's make a list through 15. 1 squared is 1. 2 squared is what? 4. 3 squared? 4 squared?
16.
5 squared?
25.
6 squared, 36. 7 squared? 49. 8 squared, 64. 9 squared, 81. 10 squared.
100.
11 squared, 121.
121.
12 squared, 144. 13 squared, 169.
Let's go.
Okay.
14 squared.
172.
No, 196. And
I
15,
knew it.
and 15 squared, we can
225.
225. Now, again, if you didn't know those, you can use your calculator. You're gonna be, you see a number like 16, maybe do a square root. Right, that's 8 times. Oh, it's 4. So 4 squared. But if you don't see one of those, for example, like when we get to 7, 20. That's not a perfect square, so something's up with that one. Okay, but if you see some of these numbers, there's a good chance it might be a perfect square, difference of squares problem. Let's try some. We're going to factor completely if it cannot be factored right front. Let's do number 1. I'm going to change it just to x because I have a up here, and if I have two a's, just on the first one, I want to have it as x, so just a little easier to explain. Because basically, I see x squared. I see 4, which is perfect square, 2 squared. Basically what I do is I'm just in my mind doing the square root of each of these. Because then I get x and I get 2. This is my a value and this is my b value. My a value is x and my b value is 2. And that's what goes right here in the expression. It's just going to be a plus b, or x plus 2, a minus b, x minus 2. Yeah. So I'm doing a square root because I just want to, I need it's a perfect square, but I need it to be something squared. So basically I'm writing 4 as 2 squared. And so this is my b value inside. So it's kind of the square root values are actually the a and b that you use. Again, all of these you can FOIL to check. The x squared would be minus 2x plus 2x, which cancels, and then a minus 4. And so we get back to the original. Yeah, this is one of my favorites, by the way. My favorite factoring technique. So let's see. Okay, so there's our first one. Basically, you're doing a square root to just get the a and the b values, and you plug them in. So, questions on that right now? First one. Let's do 3 because this is one like I heard over here earlier. Oh, if I see a plus, does that mean it doesn't work? Not quite, because this one there's a plus right in the middle, right?
There's a negative 16.
But really, I could turn it around, couldn't I? And write it as p squared minus 16. So now it's in this form. Yeah, it's back in this form. There's no longer a plus in the middle. Okay, so it does work. So this one, I'm basically doing a square root here. I get p and 4 as my a and b. And so I write p plus 4, p minus 4. Let's do some now where it's not just one variable, one number. It's more involved. So, is there a thought back there? No? Okay.
Wait, hold on.
Oh.
Sorry. Okay, so if they're in order and there's a plus sign, it's front.
What do you mean in order? Like this one I wouldn't even say is, really the correct order is descending order, where you put the highest exponent first. So you should put p squared first, then negative 16.
But what if it was plus 16?
It wouldn't work.
So you put
So
front.
it's never going to be.
That one would be prime.
Okay.
Or if it was both negative, difference of squares, you could factor out a negative 1, but then difference of squares wouldn't work. Yeah, so they're both positive, it doesn't work.
So with the x.
Oh, you want to jump ahead then? Yeah, so 9 would be prime. That's what she said, because but they're both positive. There's no sum of squares.
It looks like
formula.
a
Okay, let's try a few more. Let's do 6. So here we have both numbers and variables in each expression. So, is there a GCF? No. If there was a GCF, we'd do that first. Square root, though, of each of these, and I get 6. 6 and j. That's my a value. Here I get 7 and m. This just shows you each expression here can have both a number and a variable in it. And so I do plus and minus with those. Let's go back to 4. I want to show you 2 ways to do this one. That's why 4 is kind of nice. And it's kind of backwards here a little bit, like the f squared is in the second term. But that's the one with the minus. So we have this. It's actually set up how we need it. looks like it's normally like one of the variable terms here. So we can do, you recognize both these as perfect squares, right? 9, 144. They're both perfect square numbers. Let's do a square root. Square root of 144 is 12. Square root of 9 is 3. And f squared is f. And so I get 12 plus 3f and 12 minus 3f. However, on this one, why is that not the correct final answer? No, don't flip it. You can factor out more. So the problem with it, really the better method would have been right here. There's actually a GCF. So I'll show you in a minute how we could have done it with the GCF. Let's say though I had done it to here though. Well, I can make up for forgetting that GCF because I could do a GCF for this, right? 12 and 3f, I can factor out a 3. So I factor out a 3 here. And divided by 3, I'll be left with 4, and then plus f. And then over here, again, I factor out another 3, and then I'll be left with 4 minus.
Is it plus 3?
Still, there's like a times in here.
3, it's 9.
So then it's
But I
9.
thought that they had to have the same. Wait.
So there's the final answer. Now I'll show you. The better method would have been to do a GCF first.
Can you say
And I'll
f
do that.
minus 4 or f plus
No.
1? Why?
Because the variable term was with the minus here, so it has to be the b value. It's not with the a value on this one. It's got to be the b. So it's got to be the right one, the right term. Yeah, thank you. That's a good thought I didn't think of earlier. So let me just show you. Really, probably a better method on this one would have been to first factor out a 9. The GCF was 9 here. We'd be left with 16 minus f squared. Then we could do it just one step, a difference of squares with this. So it'd be 4 plus f, 4 minus f. I like that one. I mean, really, I saw 144.9. Those are perfect squares. I just did square root right away. I did difference of squares, but probably a better method would have been to do a GCF first. Let's do one more 7 to 8 to finish up. Yeah. Go on.
Can we do 5?
I do 5. It's similar to, I think it was a 3 over here or something. It's not set up correct. You can't have the plus here. Well, you can flip it around and make it 81, and then the negative r squared s squared. Then, I can do difference of squares. Square root of 81 is 9. Square root of r squared is r, and s squared is s. So that's my b value, is rs. And I do 1 plus, 1 minus. Okay, let's do one of 7 or 8 to finish up. Maybe 7. Let's do 7 to finish up. So on 7, really, square root of 20 and 5 are not; those are not perfect squares. So I need to do something first, and I can recognize 5 and 20 multiples of 5. I can do a GCF. So I have to do a GCF here first. There's no what was it? 4. Yeah, there was. I could have done it 2 ways. Here, you have to do GCF first. 20 over 5 is 4, and then a squared. 5's cancel, and I'm left with a minus b squared. Okay, now I can do a difference of squares, bring down the 5. Put a difference of squares with the 4a squared and the b squared. So square root here will give me 2a, and here will give me b. And so I get 2a plus b, 2a minus b.